Welcome to Apache Karaf Essentials. I'm Jamie Goodyear. Today we're going to talk about bundle space. That is the class loading space that we use for OSGi bundles. We're going to talk about the visibility and delegation within Apache Karaf OSGi for bundles, and unlike how they work for standard jars, we have a set of rules for finding and using classes that are a little bit different here. This has been a talk that I've been kind of putting off for a while, and I really wanted to bring this to you guys because I find that once you get the mental model for how we look at the class space within a bundle, then it really starts making more sense about how the constellation of these bundles working together start to work. So with all that being said, let's get into this. Let's start by taking a look at the traditional Java class loader. It's a very naive system, and what I mean by that is that the very first thing it sees that matches what it wants, it's going to use that. Effectively, every class can be picked up from its parent class loader, and then we can finally see what's on our class path. So what that means is that when you set up your application and it wants to find a jar, it's going to ask the parent class loaders, and that's a chain of class loaders, find me that object, find me that class. And it's going to go all the way up to the top and then start working its way down. So the way that looks is like this. We have a delegation pattern, and we start at the very top. The bootstrap class loader. The bootstrap is the first. It's going to check for the most basic classes. So that's going to be stuff that's at the very core of Java. Next level is the extension class loader. That's where we're going to start searching things such as the JRE libraries that are in your distribution. The final level of class loading we're going to look at is the system or application class loader. That's the more traditional one that we're mostly familiar with. That's looking at the class path and hey, here's all these jars in a row. We want to get an object coming from one of those. Pretty straightforward. Getting back to this now and passing by the delegation part, let's look back at just the basic Java world we have here. Our application wants to be able to use a class from jar foo. We're going to assume that's like package org.foo, and we have some classes in there we want to use. However, this is a classic problem in Java. Now we want to pick up the latest release of that library. So what ends up happening is that you can just go and add that to the end of your class path, and hey, those new classes may be there. But the nature of Java class loading is that the very first instance it sees that match is going to be picked up and used. So in our case above, what we're going to see is that jar foo, the original, if that package and object exists, it's going to pick up and use that instead of our brand new version of it. We can solve this by just putting that brand new version of foo at the beginning of your class path. Of course, now we have a whole bunch of new interesting problems that can occur. If a package and class name happens to exist in the old jar, but not in the new one, well, our application is going to be happy because it's going to see it back there. However, now, is that actually compatible with the latest version of the library? We don't know, but at runtime, you're going to find out. Another thing that we could do is just, hey, we'll get rid of that old version, and now we're just going to run on foo. And this is wonderful. In a small application, this is absolutely what you do. And you set everything up, you run it, and you see, do we have any runtime errors? And we validate that way. But let's start taking a step back here. This is great in very small application scopes. What happens when we have a larger monolithic big application with many components, and we start bringing in third-party jars and extra components, and different teams are working on different components and have different versions of different things they want to use? All of a sudden now we have this class path that is very large, can have lots of duplications, and do you know where anything is particularly coming from? If this sounds familiar, it's kind of known as jar hell, and it's something that OSGi helps a lot with. That brings us to our topic, bundle space. When we use OSGi, we have to start thinking about terms of what is the class bundle space that we have. What I mean by this is what classes are available to that bundle and are visible to that bundle and accessible to that bundle. So we're not looking at the original class loader. Now we're starting to look at this larger set of spaces that we're able to use. So under OSGi, we start thinking about, hey, we have bundles A, B, and C, and each one of those have its own space, its own ecosystem of classes that are available to it. Stuff that's available to class or bundle A and say bundle C may be completely different depending on how it's been set up. That's part of the magic of the system. So let's take a closer look at just the class base for bundle A. An easier way to think of this is that when we take a bundle, that jar we use in OSGi, we can split all of its dependencies into two sets. One are private dependencies, so those are the packages that we use within our bundle, but we don't need the rest of the world to know about that. It's part of our secret sauce. And then there's the public dependencies. These are packages we get from the runtime container. We'll tell it, hey, we want this particular package within this particular range, or we can put some extra requirements upon that. But the most general thing is that these are publicly coming to us and we're going to take them and be able to use them. Now, each bundle in the container has these private and public spaces. And when we start thinking about this in a larger scope, where every one of these bundles have this dichotomy inside of it, we have to start thinking, well, how does this expand? How does this actually start working on a larger scheme? This can get complex. Well, what we need to do first is just let's take a really close look at what's happening in bundle A, and then we'll talk about how we delegate this to a larger system. In the example of our bundle A, where we have the known private packages that it needs to use, that's what we've declared within our Maven build problem. It was saying we have these dependencies we need to have, and we have that internally met. And we have a set of public, we need to get these from our environment. When you start thinking about what does this space look like, though, as a developer, well, I can think of myself as that when I'm running this bundle, I know I have the provided set of packages that I've built into my bundle, and I also have this set of additional packages I'm taking in from the environment. But when I want to think about where they're coming from now, I can draw out this diagram where I can say, hey, I know that I have some dependencies from bundle B and from bundle C. And when I think about my class space, it is now larger than what's within my bundle. This is a little bit of a different way of thinking, because when you're thinking classic Java, you always have your jar and you think your class path, and I can just take whatever I have in my jar and pick something off from that class path as I need it. Now I'm thinking about, hey, I have something within my bundle, but I also have pulled in little bits and bobs of all these additional packages. So what does that delegation look like? This is where things get a little bit interesting when you want to think of it. We start with our bundle class loader, and now we can pick things up, yes, directly from the environment. So we can say, hey, I need to take this up from my parent, which is going to pick some things out of JVM. That's when you want to grab those simple JRE kind of libraries, and you're pulling that in. That's a runtime dependency. You can also be reaching out to the system bundle level and saying, hey, OSGi, I need you to pull in these couple of extra things. Those are getting wired into our bundle. Normally do that during the resolution. We're wiring up our bundle for runtime. And then at runtime, what we're saying is, hey, I need to delegate to those other class loaders. So if I'm in bundle A and I need something from bundles B and C, I'm reaching out to those other bundles and saying, I need something from your class path, and pulling those packages in. And that way I can use that then at runtime. This is slightly different. This is now a chain delegated way of being able to reach out to other packages to say, I need those classes so that I could do my runtime. That being said, this big diagram is a little complex, but it does illustrate to us the power that happens now in an OSGi system. Your class loading is no longer just being limited to saying, hey, here's this shared pool of resources you can go grab. Now you have multiple different pools that you're able to reach into and pull out what you need. This is part of how we're able to say in our runtimes, when you're running an application in Craft, that, yeah, we have 2 or 3 different versions of that library, but my component only needs that one, and it only uses that one, and the other department's component, it runs, and it can pick up what its set of libraries it wants. And we're working here side by side in the running JVM without having ourselves stepping onto each other. This is the mechanism by which that occurs. So with that, and that heavy bit of data that I just gave you, I want to thank you for joining us on this conversation. Please reach out into the comments and ask any questions you want. I do plan to do some future videos on the Maven bundle plugin to start showing you how to talk to the system for what you want to pull in for packages and how all those various parts of that bundle plugin works. Outside of that, please like and subscribe to our videos, and thank you so much. Have a great day.